Hello grade 12s, welcome to my channel, and let us have a look at some term 1 material formats. Alright, and this time we're going to use the same November 2024 final exam paper to just introduce the topic. So far we'll just solve and try to highlight certain important areas to focus on, and maybe some nuances that need to be appreciated. And as we continue, I will then curate some sort of a course. Maybe it can be a 3-hour course where I try to, get you into the crux of the matter. And hopefully this can assist in ensuring that you get the maximum benefit as you progress in grade 12 mathematics, especially for paper 1. Now let's have a look at this question 2. So question 2.1 reads that the first term of an arithmetic series. Now it helps to know what series are we talking about. It is arithmetic. So we can write A as the first term is 7. So we know that A is equal to 7. And the common difference of this series is 5. So we know D is 5. And the series contains 20 terms. So we know that N is equal to 20. So this is good. Now, question 2.1 says, calculate the sum of this series. So this is easy. It's arithmetic, so we know Sn is equal to n over 2 into 2a plus n minus 1 times d. This is the best formula, but I mean, one can decide to do the last term first and then do this calculation. Otherwise, it's all unnecessary. So this implies that S20 is going to be 20 over 2 into 2 times 7 plus 20 minus 1 into 5. Therefore, our S20 is going to give us what comes out. So we plug this into the calculator straight away, not waste time. 2 into 7 plus 20 minus 1 into 5. Just ensure that the substitutions are correct. Okay, so this is 1090. That's it. Because we don't know what this is, we can't put a unit to it. So this is very easy, guys. Substitutions, answer, easy 2 marks. Most important though is to show the formula that we are using as per the instructions that says we need to clearly show everything that we're doing. In all calculations, we have to be elaborate. If we used a particular formula, we must volunteer that formula, then substitute, then get to the answer. Okay, not a problem. So we have 2.1.2. Question says the original series is extended to 75 terms. Okay, now we've got 75 terms. Now the sum of these terms, again, see the sum of these terms is 14,400. Now using sigma notation, very important, we almost always have to do something. Either we solve a problem that is presented in sigma notation, or we may have to write in sigma notation. So the question says write down an equation for the sum of the terms added to the original series. Obviously, guys, we need the general term for the sigma notation to be written. So we know that Tn is going to be A plus N, minus 1 times D. This implies that Tn is equal to A is 7 plus N minus 1 times 5. Therefore, Tn is going to be, if we multiply 5 there, we get 5n. 7 minus 5, that's plus 2. Okay, so what can we say? We can say therefore the sigma starting from 1, and then we were told there's 75 terms, so we know that this goes up to 75 because 75 minus 1 plus 1 gives us 75 terms. Now here we write the general term 5n plus 2 should be equal to 14,400, and that's it. That's that. Why does it look slanted? I hate it when it does this. Please do not slant. I hate it. I hate it, but it looks like I slanted my writing instead. Anyway, so guys, this is not a very difficult question either, because what is important is to find what we want, right? And then we know that the left hand side needs to be right and the right hand side needs to be right. How many marks? 4 marks. And then we can say substitutions there. So this is easy, not a very difficult question. So to write in sigma notation, key is to find the nth term or the general term of the sequence, because it comes in here. All right, so that's it. That's that. So we don't complicate our lives at all. So let's have a look at question 2.2. Maybe let's just do it on a new page. Now 2.2 says the sequence of the first differences of a quadratic pattern is as presented. So we can clearly see that, well, we've got a quadratic pattern which we know is going to be T1 going on to T2, going on to T3, going on to T4, and this continues. But we know the difference between the first two terms is going to be that first term of the first differences. Difference between the next two consecutive terms is going to be the second term of the first differences. The difference to the next subsequent number of terms is going to be the third. That's a 5. Why is my 5 now looking silly? Okay, this is a sequence on its own, so it keeps on going also. Not a problem. So now these are the first differences. Of course, in a quadratic pattern we have second differences, so this, guys, needs to be done. We can see it's just a 2. Okay, so as we can see, the second difference is sort of common or constant. Now what is the situation right now? It says if T99 of this quadratic pattern is 9,632. So we can say, well, this is T99, which is 9,632. Okay, doesn't really matter, this still continues. Now we are told to find T98. So obviously the preceding term here is going to be T98, right? Right, and this is what we want as to what is the value of T98. Okay, as you can appreciate, guys, the difference between these two Now look at the pattern. If we're looking at the difference between T2 and T1, we get T1. The difference between T3 and T2, we get T3. So as we can appreciate, is that this term, I'm just trying to make you look at something. The difference between T2 and T1 correlates with the first term. So that means the difference between T99 and T98 is going to give us T98 here of the first differences. So this is key. So we need to find out what is that value. Because once we find that value, we just simply take that number, we subtract this, it gives us the actual T98 in the quadratic pattern. So this is very important to note these kinds of things. So these are some of the highlights I just want you guys to pay attention to as you progress in this kind of situation. So 2.2.1. Now we need first the Tn, which is T98 of the arithmetic pattern, which is the sequence of the first differences. So we know that Tn is A plus n minus 1 times d. This implies that T98 is going to be A is 1 plus, now n is 98 minus 1. The common difference is 2. Therefore, T98 of the first differences, we just plug this into the calculator. This is 1 plus 98 minus 1 into 2. It gives us 195. Okay. Now we've got 195 there. This is the value right here. Oops. So this is equal to 195. Now we can say, therefore, T98 of the quadratic pattern is going to be equal to 9,632 minus 195, which is going to give us what we want. So this is going to be 9,437. Very easy. So as I said, guys, understanding how things work together, it helps a lot. So what is important here? How many marks first? 3 marks. So of course substitutions and this answer and the final answer gives us our sweet 3 marks. So as you can appreciate, these questions are not really difficult, but they are certainly challenging, because if one doesn't understand these patterns properly, then it becomes a bit of an issue. So that means a bit of an inspection in these. So when you practice these topics, or you practice these sections of maths, ensure that you do a due diligence in looking around, inspecting everything. The book can give a perspective in general terms, but it is upon the student or whoever is their coach, teacher, tutor, to ensure that the background is investigated and well understood. Because with this knowledge, obviously this was the bullet to winning in this situation. If one didn't know that, then it becomes a bit challenging to get around this problem. Okay, but there's many ways of killing a cat, guys. But if you look at mark allocations, you would know that you don't need to sweat. Okay, so there's no need to sweat here. We just go about it easily. But you can complicate your life here if you will, because you can make this into one big step, using the quadratic pattern in general, using this, and then using this in general, then getting to this, using the second sequence again, using this, then you have this long, lengthy, complicated equation, but it does solve the problem in the end. So sometimes you choose the best approach so that you can get to the answer much more quickly without losing too much time. It is important to be economic as well, because that's what matters in terms of finishing the paper. Anyway, it is further given that the third term of the quadratic pattern is 32. Okay, so we are told that T3 is 32. Maybe let me write it differently. So T3 is 32. Okay, not a problem. So we have to determine the general term of the quadratic pattern. Okay, this question is common, guys, but you can see it's no longer the standard one. It's one of the bit tricky ones, but it's not a big deal. We appreciate that the common constant second difference is denoted by 2a in general, and the very first term of the first difference is denoted by 3a plus b. But now we don't have T1, we only have T3. Now T3 is going to challenge us into using a bit more, but it's not a problem, we'll get to that. So we can start with those, easy. So we know that, well, 2a is equal to 2, therefore a is 1, okay? This implies that 3 into 1 plus b is equal to 1, as you can see there, using that sequence of the first differences. So therefore b is going to be minus 2, right? Right. And now we can say then, what do we want? We know that T3 is going to be equal to, remember this is an, so this is going to be an squared plus bn plus c. Okay, this is the general quadratic pattern, which will imply that T3 we were told is 32, a we found is 1, now this is n squared plus b we found out it's minus 2, and plus c. So this is it. Oh, sorry guys, I'm making a meal now. N is 3, so because this is T3, right? Yes, trying to complicate my life now. So this implies that 32 is equal to 3 squared is 9, so 9 times 1 is just 9. And then this is 6, so 9 minus 6 is 3 plus c. Therefore, our c is going to be 32 minus 3. Okay, that's 29. Okay. So we can say, therefore, Tn is going to be equal to n squared minus 2n plus 29. See, not so difficult. It's just that this portion needed to be understood. You can use any term in the quadratic pattern. Even if we didn't use this, we could easily have used that T99. So it doesn't really matter what we do, as long as we can just work it out nicely. This was just for a student to not struggle with these big numbers. Otherwise, the examiner could have left it to the student. We've got 2 terms in the quadratic pattern that we could have used, because this will apply for everything. Okay. Very good. Now, let's check if indeed this is true for our quadratic pattern, because as I said, folks, once we find an answer, we need to check whether it makes sense. Now we need to find that T3 is 32. We need to also prove that T98 is what we calculated, which is that, and the last term is that. If those three tie up, then we know we are good to go. Of course, I'm just going to try and complicate it a bit. Okay, we said T3, so that's going to be 3 squared minus 2 into 3 plus 29. We get 32. Now if we change this is 98, where n is, and then guess what? We find 9,437. So with these fancy calculators, guys, we can do this very quickly, because once we have the framework, we are good to go. And indeed, T99 gives me 9,632. So this is indeed suggesting that our answer is correct. Please, folks, refrain from moving forward without ensuring that the gymnastics performed are proper. Okay, so this is 5 marks, so there's going to be a bit more here. So we're going to get 3 marks there, and then we get a mark for A and for B. Okay, so this is it for that question, guys. Very easy, 14 marks. Not a big deal. So we move on. So indeed, there will always be a question on the arithmetic sequence and doing the sum, and as well as sigma notation, whether geometric or arithmetic. Okay, it's always there. And then we will always have a question on the quadratic pattern. This is from grade 11. So we need to master these as well. So let's get to question 3. Now question 3 reads, a circle with a radius of 6 centimeters is drawn. A second smaller circle is drawn through the center of the first circle and also touches the first circle internally as shown in the diagram. So this is the big circle. So this is suggesting that, okay, this is its radius, right? Radius is from center to circumference, and we are told this is 6 centimeters. Okay, don't know what that is. Okay, and we drew another circle from that center. That means its diameter is going to be the radius of this bigger circle. Now that means its radius is going to be half the radius of the bigger circle. So this is going to be 3 centimeters. Okay, it helps to analyze these things, folks. And what else? We're told a third smaller circle is drawn through the center of the second circle and touches the second circle internally. Again, that means this circle's diameter is going to be the radius of this second smaller circle. And so its radius, if we just say that's the center, okay, I don't know why I'm getting this curvilinear line. So that means this is going to be half of 3, which is 1,5 centimeters. So this is essentially what we can see. If we were given a radius, it's best sometimes to keep with the radius. So this is what we have, folks, and that's about it. So sometimes there will be a pattern given. It's not always the case, but sometimes a pattern is given. So one has to pay attention to that pattern so that we can answer questions properly. Now we are told that the process of drawing circles continues and forms a geometric pattern. Here is the most important. This gives us a geometric pattern. So that means the relationship between the sequence of these circles, whether in terms of their diameters or radii, even areas, or we call it area, isn't it? Yes, so it would form the same geometric pattern. So again, there are certain inferences, or should we say implications. A given statement, sometimes we need to assess and be sure, what does it really stand for? So if everything is related like this, so that means we are going to have a geometric pattern, even if we're looking at radii, the sequence of radii here, or the sequence of diameters. Since these are very important in calculating the area of each circle, therefore this means area here also, the sequence would be exactly a geometric pattern. So this is very important, but at times you may not be so sure. You may want to check it on a rough work just to make sure you're not making an assumption, if you are not convinced, of course. But with ample practice throughout the year, this should not be an issue at all. Now the first question says we need to write down the radius of the third circle. We already worked it out nicely. So we know that we have 3.1. So we know that the radius of the smaller circle is 1,5 centimeters. We walk away with 2 marks. Okay? Because, I mean, analyzing this and really committing to it already gave us that answer. And here nobody cares about how you got it. It's all about how or what it is. Now we need to calculate the sum of the areas of the first 10 circles. Now can you see? Areas. Now what do we know? You can just say the sequence. Come on. Of area. Is it area or is it areas? Hey, but what? Is it like this or is it like this? And now this is the thing, the first circle, remember we started with the big one, so this is going to be pi r squared. This is 6 squared. We go to the next one, it's going to be pi r squared, so this is pi 3 squared. And then the last one is going to be pi into 1,5 squared. And then we knew that this goes on until Jesus comes, okay? But we know that we wanted the 10th one, but we're not going to bother ourselves because all we're interested in is the sum of those areas, okay? It looks like I was crazy also to say area. It's areas. Oh, yeah. Sometimes the terminology can twist your tongue, isn't it? Okay, guys, so we were told, like I said, if the radii sort of form this geometric pattern, that means everything related to the radii, that is diameter or area, because area is also related to the radii, so it will also form a geometric sequence. But if not convinced, a student has to perform a check on the rough work. So this is advisable because we can't just let these marks go. And of course we need to be aware that sometimes time is going to have to be spent, okay? So we just need to spend it wisely. Okay guys, so this is a geometric pattern, so we know this means R is going to be, the second one is going to be this one divided by the other one, and we know that the pi is going to go away, and then we have 9/36, which is nothing but 1/4, a quarter. So this is it. Of course we can even check the others, it's not a big deal, but since we were told this would form a geometric pattern and we were given radii, we know that anything that would have a radius involved here would essentially give us the same pattern. Now what are we doing? The sum, and we can see here the sum is less than 1. So which formula is going to be important? We know that Sn is A into 1 minus R to the n, all divided by 1 minus R. Of course, we always have to choose the best formula for the job, okay? This implies that S10 is going to be, now a is pi 6 squared into 1 minus a quarter to the exponent 10 all divided by 1 minus a quarter. Therefore, S10 is going to be, now let's just punch it onto our calculator, shift pi into 6 squared, all that into 1 minus into a quarter to the exponent 10. Then we close that, come down, bracket, got 1 minus a quarter. So our calculators, guys, are very nice and friendly. So I'm getting 150, comma, now to 2 decimal places according to the general instructions, we will get 80. Remember, we need to maintain the general instruction. We can't jump it. It's at 2 decimal places unless otherwise stated. So we have to maintain these 2. But now, this is the sum. Remember, an area is depending on what we were given. So this was in centimeters. So this is centimeters squared. Do not forget the unit of measurement. If you do, so when this is specified, we cannot forget the unit of measurement, and it has to be correct, guys. If this is not correct, then this is nothing but suicide. Okay, this is 4 marks. This is not a problem, guys. Getting our common ratio was important, right? Substitutions into the correct formula, right? And that answer. Okay, so this is what we have. Now we are scoring how many marks here? 4 marks. That's strange. Okay, but for me, guys, I mean, there's nothing really. I mean, if one shows the sequence, that's also okay, but the final answer can get 2 marks, first for the value and second for the correct unit of measurement. It depends on what the examiner feels is of importance here. The job of a student is to show everything so that everything is covered. But remember, when the answer is correct, the operations are correct. Even if you didn't show the sequence, you will still get your marks. But if we have a situation where the answer is incorrect, then we start looking from the steps. Where do you deserve a mark? Of course, if the approach proposed by the student is featured in the memo, then it's easy to know how to mark that student. But if the student used a different approach than the one proposed in the memo, then it's upon the marker to now use their understanding of the subject and logic to see where to score. I mean, where to give a mark for the student. And of course, when in doubt, a consultation needs to be done. No ignorance here. So we can't have people who are just miserable, who want to get the job done because they want to go home to their families to enjoy Christmas and many other things. So we can't have, average teachers, let me put it that way, or novice teachers marking these scripts. It's incorrect. In fact, it's illegal, because automatically we are sentencing students who actually deserve more than they would get to getting very little. All right, but hey, guys, this is just my opinion. It's nothing but a thought in my mind. It may be wrong, whatever. So that's it. We've got our 4 marks, nice and easy. So let's look at 3.3. Let's not make this too long. It says now that which circle has the diameter? Can you see? It's still related to the radius. So this means it's still a geometric pattern. There's no need to sweat here. Is this 3 over 128 centimeters. Now we need to say now the sequence of diameters is going to be the first. Remember, this was the radius of 6. Remember, the first is the big, so the sequence is getting smaller. So be not confused about the direction. Don't start with the smaller and go to the bigger. Remember, we started here and we're narrowing this down until nothing happens. Okay, so don't make that mistake. The first diameter here is going to be double the 6, which is 12. Okay, we don't really need to put the units. Then this one is double the radius, which is 6. The next is double the radius, which is going to be 3. And then this goes on and on. We don't really care how long it goes, it just goes on. But what do we know? This is a geometric situation, so it's going to be 6 over 12, which is a half. Okay, not a problem. So this is what we have. Very important. Now we know just here it's all about the term in the sequence, because if we're asking which circle has, we just find the term in the sequence. It will correlate with the circle. So we know that, well, Tn is equal to a times r to the exponent n minus 1. This implies now Tn here is the diameter. So this is 3 over 128 equals a, this is 12, into r, which is a half, to the n minus 1. Okay. Now we can clearly see that we need to divide by 12 both sides here. So we get 3 over, so we just have 128 by 12 here. Wait a minute. Let's see. This is 3 over 128 divided by 12. Okay, so I'm getting 5/112. Okay, so this is 5/12 equals a half to the exponent n minus 1. Now, is there a relationship? 5/12 looks even, so I can perhaps express this as base 2. Maybe this whole thing as a power. Oh, sorry guys, I'm making a mistake. Now this is not 3, it's 1. Okay, so this, I can say this is a half into, let's see, what is 5/12? Now the key to doing this, you just take 5/12, you press equal sign, you get 5/12. I don't know what's happening here. And then you go shift, fact, what do we get? So let's see, 5/12 equals sign, shift, fact, get 2 to the exponent 9. Now this means I can just put that exponent over there. So can you see, guys, quick ways, get the job done. Now once we have powers with the same bases that are equal, that means the exponents are equal. So it means 9 is equal to n minus 1. Therefore n is going to be equal to 9 plus 1. Okay, so I performed some crimes here. So this means 9 is equal to n minus 1. Therefore n is equal to 10. But remember, that's not the question. Of course, this is the 10th circle, because the 10th diameter is going to be the 10th circle. So we can say, therefore, the 10th circle will have a diameter of 3 over 128 centimeters. Nice and easy. Okay guys, I was just pressed for space here, but I'm trying to not go beyond the space that I have. I don't know why I pushed myself so hard. Of course, guys, this is a side calculation. This is just a thought. If you don't know this, you can easily just introduce logs here. You'll still get to the same answer. But shorthand techniques avoid a lot of trouble for a student. Anyway, folks, this is very important. Again, getting this is important. And substituting into some correct formula, it's also important. And essentially, how many marks? 4. I think answering the question is important. This was a means to an end. Maybe also showing us the sequence, we can get a mark. So it depends on how the examiner feels about it. Because as you can see, I said before that algebra is heavily applied here. As you can see, the issue of exponential expressions comes in here. But remember, when applied, sometimes we can get a mark, meaning changing this 512 into a half to the exponent 9. That could be marked. So this is a potential for some marks. Maybe the 4th mark is there. I don't know. Showing us the sequence could be considered for a mark. Anything, guys. So only the formal guidelines can really free us from the trouble. So in any case, if everything has been performed properly, we get our total of 10 marks for this question. And that's it for sequences and series. I hope you guys enjoyed the video and you have learned what is necessary, and hopefully you have been able to follow on nicely. Now, this was just me trying to give you a worked example as you would be given in class by a teacher. Don't worry about the fact that this is an exam type question. Again, for me, we have to do goal-directed activities here. So it's just to show questions that are at the level of the examination so that we don't really faff around too much on too much basic stuff. Not to say don't learn basics. Go back now. Take any study guide, any textbook that you may have inherited from the previous class or whatever, you bought it preparing for this year. Start going into sequences and series. Do everything there. Review grade 11 quadratic sequence. And of course, once that is sorted, do every example in those study guides, every single one. Trust me, don't leave any stone unturned. What I can assure you is that those very questions in the study guides, in the textbooks, actually are questions from some past examinations. Some of those questions may actually pop up in the next exam, because the idea is teachers know students don't really pay much attention to those because they look at those for granted. Then you find that a question in some classroom textbook of maybe of old, the ones that we used, is going to come up in the exams. So if you have access to those books, don't think they're outdated. Maths is never outdated. In fact, I find older books are much better for a student to use even if you don't have someone to teach you. Problem with these new textbooks, there's too much focus on unnecessary things, and most important, core areas are not clearly elaborated or clearly defined, and students end up suffering. So it doesn't really matter though. Some good books are still present, even new ones that we have never seen. But for me, I feel more comfortable with the older textbooks because I know I used those alone mostly, and I never really needed much support from my teachers or my peers. But again, you may not be like me. Everybody is unique in their own way, so they have special abilities that probably cannot be compared to others that much. But all I can say is, if you do your part, guys, you will go far. But if you watch things happen, you will always be wondering how they happen. Otherwise, I hope this settles a bit of, your fears about this segment of maths. Please practice. Use this video to introduce yourself into this topic if you are still new and shaky about it. But if you're already feeling comfortable, you're one of the matriculants of last year and maybe beyond last year in the past, and now you want to upgrade maybe in the May-June exams, this is the best time to start looking into these things. And if you are looking to upgrade maybe in November, which is the best time by the way, then of course you start this whole thing very early and make sure it's on point. I will try in most of these videos. I know I haven't been able to stick to my commitments, or should I say to my promises. I will try to attach this memo together with this question paper in the description in case you want to practice even further, because we'll still look at functions, we'll look at financial math, differential calculus, cubic graphs, probability, so that everything is on point. But I am just a bit out of the right time to sit for the entire question paper, so I'll try to handle it in sections. So my next thing now is to sit on these sequences and series and give you some proper instruction on it. And then once we get that settled to prepare for term 2, we'll then get into the functions. Of course, I'll do them as early as possible so that within reasonable time you have exposure anyway, because the knowledge of functions sometimes is applicable in sequences and series. Be very careful. For example, a geometric sequence is nothing but an exponential graph. So knowing how to deal with an exponential graph helps us to at least understand the geometric one. And the inverse to that is a logarithmic one. So please be in the habit of knowing the associations. The linear pattern is nothing but a straight line equation. Because if you look at this general term that we spoke about here, when we did the general term, can you see 5n? It's like 5x plus 2 mx plus c. Do you realize that? So those are some of the things. So these patterns are relatable. So this is more like doing sequences and series in a sort of like a mathematical modeling, some kind of thing. And these kind of things are very useful, guys, because you may sit back and say, why the hell? If I can tell you, using these patterns like y equals mx plus c, this helps us to understand how aneurysms in the brain actually occur. How do they form? We know that ideally at birth, we shouldn't expect any aneurysm to form in a baby, so that's 0. So this is basically the line y equals to x, or we should say mx, depending on how we decide what would be the fitting model of the gradient for us to use, while x is the age of the patient. Now this can tell us exactly how to predict the development of these aneurysms in the brain. I mean, this has been one of the most controversial issues in literature for many years, until the Japanese sort of started looking into these mathematical models to try and explain these kinds of things. And we can see the results pretty much fit the model, even though it's not exactly perfect, but it helps us to gain some insights into things. So math is not just taught for fun, folks. Remember, fools are going to always mislead you and tell you don't need these things. You'll never apply this in real life because they don't know. They never got a chance to know. So there's a whole lot of people who say a lot of rubbish, and probably you would want to believe them because they have their own justifications for their rubbish that they're spewing around. But here's the most important thing. Be very careful of taking so much of what you hear people say. Allow yourself a chance to explore this yourself and find out for yourself. And remember, whatever you found out, it's sometimes not necessarily applicable to the next person. So be very careful on how you project your findings. Do not overly generalize, because trust me, you're not that special as a person for the rest of the world, of course. You may be special in your own right, but that should not put others in the background. Others still have a chance to show more, okay? That's how we get forward as society. Anyway, guys, I like to talk. It's second nature to me. I don't even think about it. It just comes whenever it comes. So I hope I don't offend anybody with what I'm just saying. But what I'm trying to emphasize, folks, is that if we understand functions as we're going to go into them also, even while we're still doing term 1 material, because I'm trying to avoid a situation where in the term 1 exam, a question is heavily leaning towards functions. For example, in a quadratic pattern, we can see this is nothing but a quadratic equation. It's like y equals ax squared plus bx plus c. Now one may ask, which term would give us a maximum value of this sequence? Imagine what the hell. But if you think about it, this is a quadratic equation. So this means it's the value at the turning point. So we want the axis of symmetry. That means n is on the x-axis. But now we adapt that to the n-axis. So if you get that in your mind, I promise you, it becomes easy to answer these questions. So I'm just trying to say the functions you've learned in grade 11, please don't forget them, because a quadratic equation has been studied even as far back as grade 10, but maybe not so much as a function. I see though today, I see parabolas in grade 10 and students are working on them. So it never really was that much of an issue with us. Quadratics was something we studied heavily in grade 11. But now you guys are made to perhaps not appreciate the essence of the rest of other topics. And as a result, this is why sometimes you're not so very forward moving, if I can put it that way. Unfortunately, it's just the design of your academic curriculum. It's somehow not as best as it should be. And I don't see why people are still holding on to this, random, if I was to call it, arrangement of, how we learn this subject. And it also makes me cry that certain important sections like absolute values have been taken out. Why? Sets are not really clearly studied and learned. And these are very important because we talk of domains here when we talk of functions. That's nothing but sets. You will appreciate this also when it comes to probabilities. It applies heavily. So please, folks, don't deny yourself a chance to learn, to be the best. Remember, we study to master. We don't just study to go through the motions. Yes, 80% of the people will only get a job with this, but they will not really remember what they studied because it never really mattered to them. What was important was just to get a job eventually, which is okay. But society needs to move forward, guys. Technology is improving things, and we have to participate in this development of technology so that we're not left behind, we're not trailing other countries, and we don't end up always being the victims of any propaganda that results thereof. We need to be exactly the propaganda ourselves so that our countries can be in a better shape and our living standards can actually get better. Anyway, folks, have a good evening. I mean, this is already late. Maybe it's a good morning. So what I'm trying to say, the knowledge of functions, guys, applies heavily in sequences and series. As you can see, those patterns are nothing but algebraic expressions. We've got quadratic expressions here for the quadratic sequence. We've got a linear equation or straight line equations or linear functions for arithmetic. We've got an exponential for a geometric sequence. Of course, we've got a sum to infinity, and if you look at that, it looks more like a logarithmic function. But again, you'll appreciate these as we move along. Don't worry about all these things, but I will highlight where all of these things are so important. Okay, so I hope, I'm not talking too much. Sometimes I talk more than I'm supposed to and I even lose my thought process in the whole situation. But functions, guys, don't think when I'm teaching you guys functions within term 1 material, it's a mistake. It's not. It's deliberate, because I know those things apply in sequences and series, especially the higher order questions, which you are likely to bump into. Believe me, you are likely to bump into, but not so much in term 1 exams, maybe more in term 2, but you never know. Your provinces, guys, are crazy. Provinces like Gauteng, they like to punish students for no reason. I don't know. Limpopo is also notorious for such things. So if you're in those provinces, you might as well have everything ready for you. But if you are in my province, the Eastern Cape, the Uaska, you know, most here we don't believe in destroying students now. In fact, the papers from the EC guys, if you have not appreciated how good they are in terms of giving you a chance to even revise overall, on top of that, get the best experience, because there's some nice challenges that are actually relevant for students. And I don't know, guys, where are you? Where are your eyes? Where are your eyes and where's your mind? But of course, you do get some good questions from KZN. Yeah, I think KZN is also very fair. But it's funny how these provinces are looked down upon. But anyway, you know, most whatever is good, no one wants to talk about it nicely. But everything that's bad is always color-coded so that it's palatable, and people love drama anyway. Goodbye, guys. I'll see you next time.